Greetings, and I bring extraordinary developments to share with you all today. We have finally obtained the first photograph of 3I Atlas re-emerging from the glare of our sun following its closest approach, and what we are witnessing is absolutely captivating. Allow me to set the stage for this historic moment we find ourselves in. The 3I Atlas reached perihelion, its point of maximum proximity to the sun, on October 30th, 2025, when it traveled to within roughly 203 million kilometers of our star. Now, as of October 31st, we have successfully captured the initial photograph of it emerging from that intimate encounter. This historic photograph originated from the Lowell Observatory, one of an extremely limited number of facilities worldwide capable of obtaining images of objects that have ventured so near to the sun's radiance or are just beginning to escape it. This capacity is no accident. There are very particular technical reasons that explain this extraordinary ability. The Lowell Observatory features a substantial primary mirror with outstanding light-gathering capacity, combined with state-of-the-art instrumentation engineered to reduce stray light and generate high-contrast imagery. But here lies the critical factor that makes all the difference. The telescope mechanical framework enables it to be aimed with remarkable precision at extremely steep angles near the horizon. Imagine this as a rifle scope. This scope can be angled dramatically downward toward the horizon, which is vital for tracking an entity like 3I Atlas at these crucial moments. The reason it becomes observable only immediately following sunset or in the moments before dawn, precisely when the sun ceases to wash out our observations, and this capacity to observe at such extreme downward angles is not something every telescope can accomplish. Only a select number possess this specialized technical capability. Now, you might be questioning the brilliant points visible around the object, particularly in the lower right portion of the image. Are they stars, planets, some byproduct of the imaging process? We are aware that on that specific day, both Venus and Mercury were positioned very near the solar disk, though to this point, the observatory has not released conclusive details regarding those bright spots. It was Avi Loeb who made this image public through one of his peer-reviewed publications. And here emerges a highly relevant question that some of you may be considering. If the US government has restricted the dissemination of NASA-captured imagery, how did the Lowell Observatory manage to distribute this photograph? The response discloses something fundamental regarding how scientific investigation operates. The Lowell Observatory functions as an independent, nonprofit astronomical research establishment that operates completely separate from American federal authority. This reminds us of a crucial reality. Freedom from government funding in any nation and at any historical period grants tremendous autonomy. This financial independence is what permits them to continue their work and release findings even during times of federal administrative halts. As I committed to in my prior presentation, we must examine a striking new peculiarity of 3I Atlas. It experienced a dramatic shift in its coloration. It transitioned from a greenish tint to an intensely azure hue, and this transformation carries profound significance. Let me clarify something essential. What we are observing is not the solid core of 3I Atlas. Throughout its period of observation, what we have consistently witnessed is the envelope of gas and particulate matter encompassing it, referred to as the coma, a characteristic component of cometary bodies. Though I should emphasize the chemical makeup of 3I Atlas's coma remains quite atypical. What captivates me from a scientific perspective is that a coma's coloration consistently offers vital insights into composition and what substances a comet is ejecting. Let's outline the complete color transformation sequence of 3I Atlas. Phase 1, reddish appearance, July-August initially, throughout July and August, and 3I Atlas demonstrated a notably reddish character. This was ascribed to the extensive dust and carbon-based substances it was releasing into space, specifically molecules rooted in carbon chemistry. And I must provide crucial clarification here. When we refer to carbon-based substances, we're not necessarily discussing compounds that arose from living things. While it's accurate that living organisms depend on these substances for survival, they can emerge naturally in the cosmos through non-biological processes. Indeed, we have already observed such molecules in numerous cometary bodies in this particular aspect. 3I Atlas would resemble entities from the Kuiper zone, that fascinating expanse of our system beyond Neptune's orbit, populated by comets and minor planets that commonly include considerable carbon-based material. Phase 2, greenish-blue appearance, September. During September, a transformation occurred. 3I Atlas became greenish-blue. This green hue in conventional comets results typically from the discharge of diatomic carbon, C2. However, and here exists yet another irregularity, C2 was detected in 3I Atlas only in reduced concentrations, substantially less than the average measured in typically green comets within our system. So the inquiry persists in scientific discourse. Was it genuinely the CPU that generated that greenish tint? We also registered a pronounced surge of cyanide compounds around August 25th, which might potentially be accountable for the bluish characteristics we commenced noticing. This suggests something intriguing concerning 3I Atlas. Internal structure, it conceivably consists of stratified zones of differing composition, transitioning steadily from the expulsion of particulate matter at the surface to the evaporation of frozen material. Situated deeper within, residing within these zones, we may encounter a spectrum of carbon-based materials, compounds that, while perhaps not manufactured through biological mechanisms, constitute the essential elements from which existence can develop. And for those among you with more sophisticated understanding, an important question emerges. What about the considerable quantities of nickel identified in 3I Atlas? For those asking this query, my congratulations. You demonstrate a notably elevated degree of comprehension regarding this investigation. Indeed, the substantial nickel concentration represents among the most perplexing irregularities of 3I Atlas, particularly when examined relative to iron quantities in cometary bodies originating from our system, not universally. But in certain instances, we have documented iron and nickel. Whenever these metals are encountered, they manifest in equivalent ratios, meaning approximately equal proportions of the two elements. Yet regarding 3I Atlas, nickel prevails overwhelmingly. Enormous concentrations of nickel are present compared to the negligible iron quantities registered. What explains this? The clarification is straightforward. It originates from environments exhibiting radically distinct chemical characteristics compared to those present in our. So you might inquire, does nickel generate any portion of 3I Atlas's appearance? The response is negative. Nickel does emit radiation, yet in the ultraviolet region, something we would not perceive with unaided vision. Detecting it demands specialized instrumental filters. Having addressed this matter, let's examine what transpires at this very moment. The intense azure tint we registered proved not merely surprising, but remarkably abrupt. The object brightened quickly and dramatically. In fact, 3I Atlas is radiating substantially more intensely than the typical comets from the Oort region. Its luminosity surpasses the average several times over. What drives this extraordinary luminosity? Presumably the forceful expulsion of gaseous material, such as C2 cyanogen compounds, or ammonia. And herein lies an utterly astonishing revelation. Our computations indicate that 3I Atlas has shed roughly 10% of its complete mass over recent weeks. For perspective, although all comets experience some material degradation as they journey toward the Sun, it remains expected that their frozen material will vaporize and disperse. The quantity shed by 3I Atlas represents something extraordinary. And what renders this so remarkable? Because 3I Atlas did not make an extraordinarily tight passage by the Sun. It did not graze it as certain fabricated viral videos want you to trust. It traveled at 203 million kilometers distant, nearly matching the orbital path of Mars. This massive material loss at such a separation constitutes a profound anomaly. Another peculiarity meriting our attention: the comets frequently exhibit a warming of their hues when approaching the Sun. Not universally yet, typically. Now, color modifications in comets are not entirely unprecedented. Examples exist, though they remain infrequent. For instance, in 2015, comet 67P Churyumov-Gerasimenko transitioned from a dusty crimson to a vivid cyan as it neared perihelion. Subsequently, as it retreated from the star, it reverted from cyan back to crimson. A contrasting and even more striking instance during 2017, comet 41P subtle Giacobini-Crescak underwent a transformation in merely one day, transitioning from blue-green to crimson. Yet despite these historical precedents, 3I Atlas's behavior endures as extraordinary due to the interaction of elements. The magnitude of the shift, the rapidity of the modification, and the framework of each other, peculiarity we have already examined. For the moment, this encompasses what we possess concerning 3I Atlas. But I must emphasize, substantial additional data remain forthcoming and countless observations await examination. Also, retain this critical date. December 19th will represent the greatest proximity to our world at approximately 269 million kilometers separation, barring unexpected variations. And that moment will constitute the turning point when our most advanced equipment will scrutinize this improbable visitor. With extraordinary clarity, a brief note on solar phenomena. Meanwhile, I must briefly address a recent solar event that certain individuals might be attempting to link with 3I Atlas, yet which remains entirely unrelated. On November 3rd, a moderately powerful solar eruption of M5 classification occurred, which you can observe in these photographs. This eruption ejected a coronal mass, a discharge of energetic particles, and plasma. The source originated in the sunspot assembly, designated AR 3872, which detonated that morning. The phenomenon persisted for many hours and projected this brilliant coronal ejection outward. This transpired on the second day of the week, and 3I Atlas had been moving away from the Sun, starting the preceding Thursday. Therefore, no correlation whatsoever connects these occurrences. The sensible inquiry would be, did this eruption pose danger or indicate abnormality? The response contains multiple dimensions. Yes, it carried hazardous potential due to its possible direct consequences for our planet. In fact, NASA and NOAA announced a moderately level solar weather alert. The gentler end of the severity spectrum? No, it was not anomalous. Eruptions at the M classification represent, shall we say, secondary tier phenomena. The most formidable, representing the primary tier, belong to the X classification. Furthermore, we exist within a period of peak solar activity spanning the 11-year pattern, meaning we encounter eruptions of this magnitude roughly once each cycle. You might wonder, yet these seem to be NASA photographs. Isn't NASA facing closure? Indeed, NASA and NOAA persist in functioning under minimized capacity because of the American government administrative shutdown, though preserving essential operations. Space meteorology constitutes one of those fundamental service domains. For what reason? Because satellite communications depend substantially on space weather forecasting, rediscussing billions in monetary value should an intense solar occurrence manifest. Exists genuine possibility of solar disturbance. Indeed, as I referenced, moderate chance. Following preliminary NASA calculations, the coronal ejection will make tangential contact with Earth's magnetosphere around November 6th. Even a glancing collision of this type could activate a moderately intense geomagnetic disturbance. Yet from my personal evaluation, rooted in observations throughout the previous 12 months, NASA and NOAA prognostications have repeatedly diminished the strength of solar events. I would not be astonished if this moderate disturbance ultimately measured as moderately intense instead. Even so, it would persist as a moderate solar event and would not deliver the initial observable polar auroras visible from Mediterranean latitudes or the southern United States territories. These constitute my interpretations and viewpoints concerning this subject, and all matters we have discussed pertaining to 3I Atlas. I eagerly anticipate observing your written responses and wish that you participate in exchanging viewpoints with the broader audience of this channel. We exist within a period of extraordinary scientific significance. The 3I Atlas persists in exceeding projections, revealing fresh enigmas through each observation opportunity, and the thrilling element, our journey has merely commenced. Remain vigilant as the forthcoming days. End quote. Weeks pledge to transmit progressively remarkable findings regarding this mysterious wanderer from the depths beyond our system, until our paths converge again, and keep in recollection, discovery through scientific methodology represents an endless expedition, and you are experiencing milestones transpiring as we speak